there is no diode, two switches, switch 1 and switch 2, anti-parallel connected. Now you can see this is the input. See the output, this one to be conducted by T1 and this one to be conducted by T2. They started at alpha, here pi plus alpha, right? Very simple. Now 1 over pi, 2 because it repeats itself again, so 2 with 2, 1 over pi. Now integration will be alpha to pi, there is no from pi to 2 pi. When we integrate, we get another formula. We may use another circuit, can give the same effect by 4 diodes, by 2 diodes and 2 switches. Now, how this circuit work? Have a look. For positive, current will follow here and back to the supply. Let me change the color. For negative, current to be follow here back to the supply. You see? Now you may say, okay, what is the benefit of having 4 switches? Now 2 diodes, 2 thyristors. Now these gates can be triggered by one circuit, and whoever in forward bias will conduct. So I reduce the reduced by one triggering circuit. Definitely error, or let me say losses, will be high, because at any state of time 2 switches will conduct. As example, this one and this one will conduct together, so drop here and drop here. Compare it with the previous circuit. This is another way for the same circuit, but now we have 4 diodes, 1 switch. By the way, here either BGT or MOSFET or thyristor, whatever the switch. Now how it work? For positive, as you can see here, positive, here, the switch, here, back to the supply. When it's negative, here, to the switch, back to the supply. At any instant of time, 3 switches will conduct. And for the current I, okay, you can see that in either way, this thyristor will see the current in one direction, okay, in one direction, as you can see. Now let's take example. A single phase full wave AC voltage controller has a resistive load. Given the resistive load, the voltage given, frequency, it seems to be the same previous example. The difference is the circuit itself. T1 and T2 are equal. Now the alpha is pi over 2. He asked me to find RMS output voltage, power factor, average current in the thyristor, and RMS current in the thyristor. Average and RMS. Now for output voltage, we have formula, we substituted, we got it. Now VO over R give me the output current. I square R give me the output power. VA is the input power, as you can see here. I divide them to find the power factor. We got it here. Now for IA average, it will be integration from alpha to pi. I divided by R because this is voltage, divided by R to give me current. And I got this formula, and the final answer is this. Now the same case, but I will square the voltage and take the square root, because this is RMS. And also I got the current, as you can see here, from here to here. This is delta, time of conduction. Remind you with the equations. See here, when I talk about the output voltage, I have Vs, alpha and beta, everything. Just substitute, do the calculation. For the RMS current, okay, again, I have here a formula, but this formula cannot be solved directly. You need to write code, numerical method, use one of the numerical method to find the solution. You cannot find it directly. Now I got it. I got R. Square root R, IR will give me I output. IA also, we cannot find it directly. We need numerical integration. We have the formula, but we need to apply numerical integration. Now power is I square R, we got it. Volt ampere, input voltage given to me, the current is the same. I got the input power. Divide them, you got the power factor. Now what about 3-phase? 3-phase, we can put the same anti-parallel thyristors for each phase, A, B, C. So 6 thyristors. And just to remind you, we are talking about balance system. Balance system, it means VAN is maximum sine omega t, maximum sine omega t minus 120, maximum sine omega t minus 240. And if we subtract A minus B, B minus C, C minus A, we find line to line, as you can see here. Have a look. From here to here, 0 volt. From here to here, the voltage is 0.5 VAB. From here to here, the voltage is 0.5 VAC, and then 0, and so on. So we take them one by one. You see here, between 0 to pi over 3, pi over 3 to pi over 3, and so on. So at the beginning it was 0, as I explained. Then VAN will be VAB over 2, 0.5 I say, VAN VAC over 2, and I have the voltages, everything here, VAB, VAC. I just need to multiply, as you can see here. So we got for each period. I will stop here. We will continue in the next session. Thank you.